Welcome to this session, which I've called a sneak preview, because our book, which is here, was published on Friday, and the official launch is going to be in a couple of weeks. Joe and I are the editors of this tome. And we're fortunate to have two of our chapter authors here who are going to speak to you in a moment. Alex Linus on stone and Barbara Jones on straw. This is the table of contents. I don't know how much you can see here. We tried to make the book as easy to navigate as possible, and hence the materials are deliberately arranged alphabetically. We wanted to put both conventional and emerging materials on a level playing field, and you will see that some chapters, the big three, concrete, steel, timber, are longer than, say, mycelium, which is in early days and still awaiting BBA certification. All the chapters follow the same structure of the life cycle analysis modules. Joe is going to tell you a little bit more about that in a moment. I wanted to highlight the second blue arrow. At the back of the book, there is a short and sharp 4-page guide to EPDs, Environmental Product Declarations, which is a must-read for designers, because to get to the bottom of this whole materials conundrum, you must be able to read and distill the key information from an EPD, and they are conundrums in themselves. And Joe's short guide is a great place to start. I've just come back from my first trip to India, and I've included this slide for two reasons. First, the Vijayanagar civilization, which flourished from the 14th to the 16th century in south-central India, built extraordinary structures in granite with no mortar. And 5 centuries on, they are immutable and remind us what can be done with stone. Alex will talk to us more about stone in a moment. But the other reason I put this Indian example in is to highlight the crucial importance of local context when making material choices. And in this book, we advocate the right use of the right amount of the right material in the right place. I spotted this remarkable bamboo bridge in Dhaka, Bangladesh on Steve Webb's of Webb Yates' Instagram last week. And when I was in India, I met an architect who runs a practice of about 60 architects in Mumbai, and she expressed her deep frustration and annoyance that most international awards that recognize Indian projects focus on modest earth or bamboo projects. And her message was that these projects are not going to affect the scale of industry transformation that we need. We need to impact the mainstream. And our position in this book is that we need to do both. We need to tackle concrete and steel, but we also need to ramp up the use of materials that are less carbon intensive to produce. So the discourse has changed, and even the broadsheets have now picked this up. This is an article from 2019 in The Guardian. This is an article from a couple of weeks ago in The Guardian. And I've learned a huge amount from working on this book, thanks to all these expert contributors we've had. And I've pulled out a few facts from different chapters here. The situation with timber in this country is dire. Not only is the UK the second largest importer of timber products after China, but a massive amount goes to energy production, and we need to change that. And shockingly, more than 90% of the stone quarried in the UK is crushed for aggregate. The demand for scrap steel outstrips demand by 3 to 1, but things are changing. And this last fact about glass cullet recycling in France is an update, which is actually not even in the book. An excerpt from the glass chapter went live on RIBA Journal's website today with this updated information. because Saint-Gobain has suddenly gotten with the program in the last 3 or 4 years and is starting to collect glass cullet. And this highlights one of the challenges of a book like this. It feels like it's out of date as soon as we press send on the manuscript. But we intend to use the book as a platform for ongoing discussion of a topic that is evolving very rapidly. Now, one of the things I'm most pleased with in the book is that for each material we've included a list of questions that designers can ask when sourcing materials. And it's by continuously asking these questions and putting pressure on manufacturers that we can make change. This is Joe's EPD guide. This book also features exemplars which showcase different materials. This is a hotel in Amsterdam which makes extensive use of engineered bamboo. And this is a site in King's Cross where compressed earth blocks were manufactured with excavated site waste. And we're likely to see more and more of this happening soon, I hope. Finally, I wanted to mention that my podcast will restart next week with a series on materials timed with the book and with Joe Jack Williams as my co-host. Please do have a listen. We have episodes on concrete and brick and others in the pipeline. Thank you. Now, over to Joe. I forgot to say that the book is on offer for £35 instead of $45 today at the RIBA bookstop stand, which is on the center of the main conference program.
Hattie's much better at selling books than I am. I always forget. My role, what some of the chapters I wrote within this guide. So you're going to hear from Alex, you're going to hear from Barbara, who are going to tell you all about their amazing insight into stone and straw. But really, part of the bit that I was involved in, as well as the editing, is just getting a kind of common baseline. Each of these materials has a common requirement. Each of these materials needs a common understanding. So it's a bit about having a primer so that everybody can start to move forward. Once you start to go through these different chapters, and you'll hear from Alex and Barbara some of their detailed insights about their specific material, getting an idea of what's common between different issues is really quite a useful thing to have. So the first thing to kind of pick up, life cycle assessment modules. This is the nice Letty graphic. I'm sure you don't need me to go through them all. I'm sure you're all familiar with them. I won't get you to put your hands up if you're not. If you take one thing from the book, is you should learn the life cycle assessment modules. This is our common language for understanding the process of materials. It's that hole in the ground, to delivery to site, it's construction, it's replacement cycles, it's end of life, and circular economy. You've got to pick these up. When you have that discussion, this is the key thing. Now, no discussion of materials wouldn't be complete with a kind of use less stuff kind of angle. Yes, we can tell you what materials are good and what materials should be used more effectively and more efficiently. The first thing is to do is just build less stuff. You don't have to worry about the materiality. It's a really simple kind of answer, right? Nice, straightforward. This is from the iStruct Designed for Zero. Worth picking it up. Another great guide that we reference, and I think it's based on PAS 2080. But refurbish, reuse, efficiently use it, and then think about low carbon materials. But it's not just about the kind of carbon aspects and materiality, it's also thinking about buildings for people. Bear in mind that we're creating spaces and habitats which people are going to be involved with. So think about VOCs, think about formaldehydes, think about precautionary lists. So this is the Perkins of Real Transparency. You can think about all these kind of interesting carcinogens that we should really be considering. There's lots of great people who are experts in this, but you need to consider these in a holistic kind of point of view. The final one here is Design for Freedom. It's not just the material impacts once they're in a building, but thinking about that supply chain. Think about how you can make sure that your buildings are free of human slavery, child slavery, all those kind of things as well. So again, when we're designing stuff, we have an impact on this. So pick these kind of bits up. And then onto sequestered carbon, there's a nice little section in the book all about sequestered carbon. Sequestered carbon is a question I get asked more than anything else, probably, because it is kind of complex. But it takes you through the ins and outs about understanding with any bio-based material what the end of life is and how that kind of fits in. And I strongly disagree with how we do it currently, but that's probably the way I look at it. If we were to follow the Rick's guide, it'd come up with a slightly different answer. But we'll talk through all of those kind of bits in the book. I could do 2 hours on it right now, but I won't bore you to death with that. And the other kind of final thing I want to talk about in terms of material sourcing is the biodiversity crisis. I know there's a talk tomorrow, I think, with Eva and a few others talking more about biodiversity. If you think about the materials that we use on a regular basis, some of them come from holes like this, some of them come from far worse holes in the ground, some just come from a field. So really think about, again, is this the right way to do it? These things can probably be repaired, but how long does it take? 10 years, 15 years, 5 years? Until you know the answer, how can you make an informed decision? And then just finally, Hattie hinted at this earlier, this, for those who don't know, is what an EPD looks like when you pick one up, an environmental product declaration. It's dry, it's horrible, it's very daunting to pick up when you first look at it. I've got a really short guide, it's 4 pages. I think we all need to be conversant and understand how we read an EPD, and then you can start to make better informed choices. So with that, I'm going to hand over very quickly to Alex, because Alex and Barbara have got far more interesting slides than I've got, right? So we'll spend more time with them. Thank you very much.
Hello everyone. As Joe said, I'm going to be talking about stone. I'm a structural engineer, so most of our stone experiences come from sort of buildings and using the material, trying to use it in effective ways. Just so I'm not going to be just showing pretty pictures, I'm going to be trying to talk to you about how it works as well. So, we've been using stone for thousands of years. As Hattie's images showed, we used to be really good at it. We used to use it for everything. It really is the original part of architecture and engineering is using stone to build things. It's one of the first things we used to build with, as well as timber. These are a bunch of examples of actually very modern buildings. So even the oldest one here, I think, is from the 40s or 50s on the top right in France. So this is sort of proving that we can use stone still. It's not just a cladding. We shouldn't be thinking of it just as ornament and decoration and something that looks pretty and we can slap it on the side of our buildings and then make it look like it's an old building. We should be using it as load-bearing. We should be using it for its best of its abilities. As Hattie mentioned as well, the vast majority of the stone we quarry in this country gets immediately crushed or immediately burned into limestone and cement. So you can see the bubbles there. The first 2 are all cement industry and concrete industry, really. It's a pretty big shame that we've essentially crushed all of our good building stone and become really bad at actually extracting its blocks. The image below is from a quarry in France where they extract large blocks and then they cut it down into exactly what size they want, so they then can produce large blocks and they can build large structures with it rather than immediately crushing it and then shipping it to somewhere else to be mixed back together into concrete. The stone manufacture cycle is also very simple in its base form. You're really cutting blocks out of the ground, taking them somewhere, doing a bit of shaping to them, and then building straight away with it. The majority of the carbon and cost and energy will happen in one of these stages. This is a kind of summary of the difference between carbon and cost in stone. And quite unusual with a lot of materials is that there's a big disparity between where the cost is in making stone and where the carbon is. Most of the carbon for stone comes from transporting it from the quarry to the manufacturing and then to site. So if you can get local stone, you can cut out the vast majority of the carbon. By contrast, a lot of the cost in stone comes from the shaping of it and the selection of it. So you're pouring a lot of stone in order to get that one really nice tile that's got exactly the right texture on it. If you can cut out those 2 things, you can cut out a lot of the cost, and if you can cut out the transport, you can cut out a lot of the carbon as well. Just as a quick aside on the carbon, here's a kind of analysis that we did. So the difference between getting it from a local site in the UK or to a site in the UK and shipping it in from China or driving it by road over to China. Really wouldn't suggest doing that, but there's orders of magnitude between the two, so this is a huge saving that could easily be leveraged. And kind of to tie back to the sadness that we don't have that many quarries in the UK that can actually cut stone of a reasonable size and then build with it, this is really the problem, is that it's actually quite easy to ship it in from Europe, but actually carbon-wise, that's not great. So we really need to start building out our quarries and teaching them how to do that again. A bit on kind of understanding stone. So as engineers, we've been working with stone for quite a few years now. We started off doing staircases. This is a solid stone staircase with steel cables running through it. So there's no other structure in this at all, other than some 12mm cables running through the stone blocks, and then it's only supported at the top and bottom. So kind of showing off what you can do with stone if you're really using it for its strengths, as in trying to lock it in compression, and then showing it all off. So there's no finishes here, there's no extra things added in. We've then kind of developed that. Stone post-tension beams are possible. We're doing quite a few projects now with post-tension beams. So this is square cut blocks to try and minimize all that processing, with bars drilled through them and then tensioned up. This is a 12-meter span beam that we did for an exhibition that's designed to take off its loadings, so kind of proving that you can do long span structures in stone. It is possible, and trying to sort of do that on more and more projects. This is then an actual project that we've done. So this is, I think, a 10-meter span transfer beam in solid stone, exactly the same thing, prefabricated in the workshop and then shipped over to site and just dropped into place just like you would a precast concrete beam. So trying to make it as simple and straightforward as possible, minimizing the processing and using good stone. We're also kind of moving on to doing a lot of hybrid stone and timber structures as well. So this is stone planks spanning onto, I think it's oak glulam beams in this case, and then all exposed, getting the thermal mass. Again, minimal processing, it's just a stone plank popped on top of a timber beam, and that gives you your entire roof. So again, it's sort of thinking about trying to build in simple ways with stone to try and make it efficient and low carbon. And that's everything I've got. Thank you. Good, Barbara.
Great, well that was fantastic, Alex, and I have to say I live in a stone house myself. It's 300 years old, and from my house I can see 3 quarries, very small quarries where all of our local houses were built, but then it's good up north, isn't it? So I teach everything about natural building to as many people as will listen. We run a school based in Todmorden in West Yorkshire, but we work all over the UK and we have worked in Europe as well. But what I'm going to focus on today is the straw, because that's what I've written a chapter about in this wonderful book. And there are different ways of building with straw. Some of you will have seen some of these methods on Grand Designs. You might have designed with a straw, you might have heard about it somewhere. But there's the traditional load-bearing method, which uses just the small field bales, and you stack them up like giant bricks. No framework, doesn't need it. You can build 2 to 3 stories high like that without any problem whatsoever. And this picture here is from the world's first council houses made with straw that we did in 2009 in Lincolnshire. And then you can build with a framework. If you're a bit shy about using the bales on their own, you can build with a framework and just fill the gaps with straw. And this picture here is from a house that we worked on in Norfolk. And it looks like a traditional house, but it's actually only about 10 years old. And then you can do hybrids, which are a mixture of framework and load-bearing. And the picture here is from the Curden Valley Park Visitor Centre, which we worked on mostly with volunteers to build the back part, the square part is load-bearing straw, and the front part is timber and glass with some infill straw panels. Very, very successful building. And now we've got available to us prefabricated straw panels. I've got some literature about those if you're interested, because we can't get a stand here yet, making prefabricated buildings so that the walls of a 3-bedroom, 2-story house can go up on site in 3 or 4 days. It's very, very fast, and it's also very affordable. So why we're thinking about natural materials is because of the environmental pollution of creating and using carbon dioxide. I don't need to go into that. But if you look at this graph from years ago, you can see the high energy materials on the left-hand side, aluminium being the most high energy to produce, but fortunately we use very, very little aluminium in our buildings. At the right-hand side, we've got all of these plant-based materials, and this is the key to it. Things that were living organisms, living plants, are the ones that store carbon, and straw is by far the best at storing carbon than any other material, even more so than timber. And the other advantage of straw is that it grows every single year. You don't have to wait 30 or 40 years for it to grow and then harvest it again. And it's a byproduct of the grain industry. We could build every single house that we needed every year out of the straw that is surplus to requirements in the UK. But before I go further into that, the chapter on straw is full of lots of technical and detailed information, because people don't realise that straw is such an advanced material. And so it still suffers from the stereotypes that people hold in their heads, and architects aren't immune to that like anybody else. But over in Denmark, so I'm working with a team of people throughout Europe, and in Denmark one of the top architects, Henning Larsen, was persuaded to do an experiment by building 2 classrooms of identical design using different materials. And you can see here the graphs of how much difference it made by using straw and natural fibres for the bulk of the materials, instead of using the ones that they normally use. And quite often, I mean, Henning Larsen were doing quite a lot with timber anyway. They weren't one of the worst offenders in terms of material choice. But you can see it makes a very, very big difference. And the problem we have is that the difference it makes is so great that people don't believe us when we talk about it. They just don't believe it, that it can be this different, and that you can build so fast with straw, and that it can be so cost effective. So let me just tell you a little bit about the EcoCocoon straw panels, because these are a game changer. They really are. EcoCocoon is a company that's working in 25 different countries now, but it's only recently come to the UK. And their straw panel system is a Passive House certified product, so you don't have to worry about whether it's going to meet Passive House standards or not. The thermal insulation is 0.123, and that's better than anything you could need. It's very, very good on fire. So it's passed its 2-hour fire test for and also what you need to understand is that in the fire test, at the end of the test you turn it off because you only have to prove 2 hours, but the structure is not destroyed. And that's a really big difference between using this material and other materials, where at the end of a 2-hour fire test you've got out of the building safely but there's no building left. That is not the case with straw. And there's a lot of other, the density is such that you've got not enough air in the straw for it to burn, but you've got enough to make really good insulation. So thinking about why would we use straw, it's that really good energy efficiency, and so that you hardly have to have any heating at all. With a passive house design and sensitive use of other materials and insulations, you can get a house that doesn't require heating. and that means you've got very, very reduced running costs, which is really focusing us now that we're in the energy crisis. The walls store latent heat, so there's a lot of mass in the walls. There's not enough as the same amount of mass as in a concrete or brick wall, obviously, but there is a significant amount of mass, particularly when you use natural plasters to... Okay, so I better move on because I want to show you some really nice pictures. There's loads of straw surplus to the requirement produced in the UK. And I think I've talked about most of these things already. People who live in straw houses talk about the ambience of inside them. It benefits your mental health and well-being. This is an area that's not really researched very much, but it ought to be, because it makes you feel happy to live in a straw house. And there's lots of questions that you might ask. The answers to these questions are in my book on straw, and they're also on the website. And just to finish off with some spectacular pictures, the Ecology Building Society has been behind straw for 20 years. So you can get a mortgage on straw buildings, and this is one of their own buildings. This is the Curden Valley Park Visitor Centre that I talked about earlier, which is load-bearing and framework near Preston. Here in London, in Haringey, the Lordship Rec straw infill building. You can go and have a cup of coffee by the lake here if you want to also experience a real straw bale building. And finally, a building with the panels built in Anglesey a couple of years ago. Great, thank you very much. And if you want to know more, I've got some stuff for you.
Thank you, Barbara and Alex. That gives you a little bit of a flavor of 2 of the 18 materials we've got in the book. There's just a depth of information. We've got a couple of minutes for 1 or 2 questions, if there are any questions from the audience. Yes, could you introduce yourself, please?
Hello, I'm Tayo. Thank you for your presentation. I had a question if the book looks at the availability of the skilled labour force for the fabrication and installation of the more niche construction materials.
So it's a bit of a tricky one to quantify because some really are manufactured. We mentioned aluminium. Aluminium has very well-defined kind of processes. Where we have stone and straw, within the book they do certainly talk about it because it's an integral part of it. There's a craftsmanship that comes with it. Interestingly, in Barbara's talk, when she talked about eco-cocon, for instance, it's a much more simpler thing to build than, say, traditionally. I don't know if you want to say.
Yes, so the prefabricated systems are designed to take the skill out of it, really. It's made in a factory and you just screw it together for most of those systems. But there are, like the School of Natural Building is teaching those craft skills. The Society for the Protection of Ancient Buildings are teaching. Lime centres around the country are teaching those skills. So there are places, but they're mostly situated in private education, which means you have to pay for it. You can't just go and learn at an FE college yet.
Time for one more, or probably got time for one more question, I think, if there are any. Go on.
Hi, I'm Lucian. I'm wondering whether your book also goes into nature positive and promoting biodiversity on a site.
Not on the site as such. There is a small section talking about biodiversity impacts right at the start, so I sort of hinted at it in the primer, where we talk about extraction and some of those aspects. Where we have materials that are bio-based, they talk about the forestry or wherever else, but we don't necessarily talk about on the site.
Thank you.
There we go. Brilliant. Well, I think that's... there's one more question and then we'll go.
Hiya, I'm Nikki Marie. It's just a quick one. about the straw bales. For the fire testing, were the panels primed or rendered with any other material, or was it just the raw sort of straw panel that was tested?
No, the panels don't need to be treated in any way. So they've been tested without any coverings. They've been tested with the standard clay plaster inside and wood fibre outside, and lime render.
Thank you.
Sorry, I think we have to wrap it up there. You can ask us afterwards. Thank you, everyone, for coming along. Copies of the book are on sale in the RIBA bookshop with a discount, £10 off today only. And if you have more questions, you can find Joe and myself or Barbara and Alex on LinkedIn. Thank you for coming along.